My name is David Bishop, and this is, well, today's October 14th. This is for EET 238, Lab 3, Part 1. And the purpose of Lab 3.1 and 3.2 are going to be making multivibrators that are meant to essentially change conditions and change states to allow this LED to light. Now, for this setup, we're on the monostable. So what should happen with the monostable multivibrator is it will not do anything until acted upon by a trigger. So in here, according to the videos that we had online for this actual setup for this, there should be a push button. However, I did not have a push button available to me, so I had to improvise. So my actual trigger is going to be this cable right here. As you can see, this cable is attached to my bus bar, and this is what I'm going to use to actually activate and turn on the LED because I don't have a switch. Obviously, a switch, all it does is open or close a channel, and this does the same thing. It's just that I don't have the cute little button that I can actually press to make it work. That said, for the most part, there was a series of calculations that were made ranging from 470K to 1 meg, and for the capacitor values between 10 and 100 microfarads. Now, those capacitors, this is the capacitor that I'm referring to, and this is the resistor. Now, each stage, these changed. We had to do calculations, and the calculations for the most part checked out with the exception of the 100 microfarad. So either the 100 microfarad that I have, capacitor that I have here, is holding a charge a lot longer than it should, or maybe the LED is just not really drawing that much energy to begin with, and that's the reason why my values were that much higher for the 100 microfarad capacitor. Obviously, here's our chip. This is going to be our monostable multivibrator. Here's our power coming in, here's our ground, and obviously these are just bridged to different things to actually complete the setup. Now, for this one, I chose to go with the 330K with the 100 microfarad because that one should last the duration of this video without being too long. So again, I said with my 100 microfarad calculations, they were a lot higher than they should have been. So 100K, 100 microfarads, I estimated it should be 11 seconds. It turned out to be 14.5 seconds. For my 330K, which is the one we're about to show you here shortly, 100 microfarad, it should have lasted for about 36.3 seconds, but it in fact lasted for 52.41 seconds. So, and then obviously for the 680K and the 1 meg ohm, it went higher than that. So I think initial calculation for 680 was 74.8, and I ended up measuring 110.7, and then for the 1 meg, I calculated 110 seconds. It turned out to be 83.17. But let's go ahead and see this in action. So I'm triggering my light. You can see the light comes on here. And based off my calculations, this one should go on for roughly about 52 seconds, which will put us just within the time frame. But obviously, I tried to set up this configuration with a switch and just not completely engaging the switch, but that did not work, so I had to find an alternate means, which in this turn just happened to be applying power to the leg of the LED. Guess I'm going to have to look at getting some actual push buttons because the switch is not really going to do the job. But for the most part, the calculations were as they should be, with just the exception of the 100 microfarad. So right now we're just going to watch as this LED goes out. And there. So this lab was a success, even though I didn't have all the actual stuff that I needed. But thank you for your time.